Hi students, welcome back. So we are going to discuss about another interesting project that is applicable in real world, that is vending machine. So here we are going to study how to design a multiple snacks or multiple product dispensing vending machine. You would have seen these machines at some public places like railway stations, airports and all, and these are very useful because they don't need any human to operate. They will be able to take multiple coins or even currency notes as your input, and then you decide which snack or product do you want as an output, and they will dispense the desired snacks. And if you have given more money, they will return your change as well. So in this project, when we are dealing with Arduino, we are going to use IR or light sensors to detect that whether the coins are given as input or not. For simplicity, to make the first version of the project, we can limit the types of coins. We can say only 10 rupees coins or 5 rupees coins are allowed. Then we use finite state machines to control the operations. What are finite state machines? We will discuss in brief in the next part of this video. Then we can use servo or DC motors to trigger the output mechanism which is going to dispense your desired snacks, and an optional LCD can be used to display that how much amount you have entered or what is the product you have selected, how much change will be returned, or if the product is not available. All these things can be displayed using this LCD. So here is the block diagram, which is fairly simple. We are going to give input coins, and we have FSM based logic which is built or programmed to our Arduino Uno. We are going to have DC or servo motors and LCD to give you the appropriate output information. So what are finite state machines? Here we have the block diagram. These are basically a digital system which is sequential in nature. So what are sequential digital systems? Which are having inputs as well as memory elements. So if you look here, we have this state transition condition and state. They are getting inputs from two different points. One is your input which user is giving, and another one is the feedback from state coming back to the state transition condition. That means there is a memory involved. Here we maintain these state values. So what are these states? States are anything that tells you about the system operating conditions which are not input nor output. Let us say the number and the values of coins. You have inserted some coins. I need to maintain a record how many coins are inserted or what is the total value of inserted coins, or in my treasury how much balance is there in my vending machine. All these things are called states. These are internal values. I don't need to tell the user that in my vending machine I have 5,000 rupees. Okay, I don't need to give that information as input or output. Number of available snacks I need to maintain. I have these many candies, these many chocolates, these many colas. I can have the total available money as a state value. So these are all internal values, right? Depending on the input and present state, then I decide what is going to be my output and next state. So let us say the user say I want one cola. So input is cola. Present state, whether the cola is available and whether the money inserted by the user is enough. Depending on all these cases, then we decide, okay, we are going to give you cola and return some money as well because you have given some extra money. So this is how the finite state machines work. Here we are taking very simple example. I have initial state. Every finite state machine has one thing called initial state. That means zero state also. I am giving an input coin which is 10 rupees. So I am assuming only 10 rupees coins are allowed. So once I insert one coin, I am transitioning from my initial state to a new state called S10. That is telling me that the current value of inserted coins is 10 rupees. If I insert one more coin, my state changes to another state called S20. That means now I have 20 rupees. Then I go to S30 on one more coin insertion. So that shows that I have 30 rupees. And that is enough for a cola to be dispensed, and then I can say okay, give the output, and once the output is given, go back to the initial state. That means now we are again at the zero balance. This is a very simple vending machine where you just insert three 10 rupees coins and one cola bottle will come out. There are no other products, no other coins accepted. And now you can imagine, if you want to explore more coins and more products, all you have to do is expand your finite state machine diagram. So what are the additional features that we can have? Definitely, we can have slots for different coins. Only one type of coin is not a suitable choice. Make more states to keep the count of total money and quantities of each type of coin, so that you have okay the record. I have 100 coins of 1 rupees or 50 coins of 5 rupees and so on. So you need to maintain that. Provision of selecting multiple snacks with different values. So some snacks are available at 10 rupees, some at 15, some at 50 as well. And LCD will display the relevant information like how much total amount is entered, how much change will be returned, and all these things. So you can also display that I have selected a candy bar or a chocolate, so that there is no confusion that I selected a cola and I am given a chocolate, because both of them had a same price. So all these additional features as a designer you can have and keep expanding your finite state machine diagram. Right. So now this project, if you want to do, it is available as an open source on Arduino community. Here is the link. You can go and work on this project as well. So wasn't it interesting to know how a vending machine works? And now you might be excited that yes, I can also build my own vending machine. In the next video, we are going to talk about another interesting application, and that is remote controlled system. How do you control an AC, a TV, a car, or anything with IR remote? What is the working principle? All of this we are going to study in our next case study. Keep learning. Thank you.